Hey guys, now I'll be telling about how this neural mechanism is happening. In my previous video, I have told about you the organization of this neural regulation, and now I'll tell you about the mechanism in just a simple flowchart like structure. So please do listen to this. Firstly, let us, this is the entire thing. It is a brain region. When you say this is the anterior side and this is a posterior side, this is the fourth ventricle part. This is the fourth ventricle part. So first let us point here the respiratory centers. This is the medulla region, this is the pons region. Now I'm sorry, I have made some mistakes like that. This is a medulla and this is a pons region. So firstly we'll be having a pneumotoxic center like this, and secondly we'll be having a apneustic center, and thirdly we'll be having a dorsal respiratory center and ventral respiratory group group. Okay, now we know this pneumotoxic center is present in the nucleus of parabrachialis and it is active in both inspiration as well as expiration. I have told you that it have no exact function. Its main function is to inhibit this apneustic center. It will be inhibiting the apneustic center. This apneustic center is present in the caudal of the pons region, and what is the main function of the apneustic center is it prolongs the inspiration, but it will be prolonging the inspiration and get inhibited by the pneumotoxic center. And we told this is the dorsal respiratory group and this is the ventral respiratory group. So dorsal respiratory group, it receives afferents from different receptors, namely the peripheral chemoreceptors and stretch receptors present in the lungs. So it receives these impulses via the ninth cranial nerve and 10th cranial nerve, and these stretch receptors by the 10th cranial nerve. So from the peripheral chemoreceptors and baroreceptors, impulses come to the dorsal respiratory group via this vagus nerve and the glossopharyngeal nerve, and from the stretch receptors of the lung, the impulses go to the DRG via only the vagus nerve. So it has come, the impulses have come here. What actual function of this apneustic center is, it will be prolonging the inspiration by acting upon DRG and VRG. Whenever this pneumotoxic center is inhibiting this apneustic center, it will also inhibit this two function and reduces or shortens the inspiratory activity. How so this is happening? How so this is happening? So afferents have come. Now efferent motor neurons also should go, no? So efferent motors will be going via the phrenic nerve. It act upon the diaphragm and the external intercostal muscles and causes the inspiration. It regulates the inspiration, whether to increase or decrease, whatever. It will be regulating the inspiration. And now coming to the ventral respiratory group, this rostral part, and we told we have three parts: rostral part, caudal part, middle part. Each of it will be having a respective function. This rostral part, firstly the rostral part, it will be innervating the accessory abdominal muscles. We know what are the accessory abdominal muscles. That the anterior abdominal muscles, namely the external oblique, internal oblique, and transverse abdominis and rectus abdominis. So what are these? All these accessory muscles, what will be they doing? They are the accessory muscles of the inspiration. They will be regulating the inspiration. And now from the caudal part, again the these nerves will be innervating the intercostal muscles and their internal intercostal muscles, and they causes expiration. We told, right, this VRG will be performing both expiration and inspiration. So this rostral part, it will be performing the inspiration and will be helping the expiration performed by the caudal part by regulating this accessory abdominal muscles, and this caudal part will be innervating this internal intercostal muscles and causes the expiration. Okay guys, this is all about the how the mechanisms it will be happening. So you remember a point, never forget to write a point like this Pneumotoxic Center or this DRG or VRG. They'll be initiating a firing inspiratory ramp. What is this firing inspiratory ramp is increases the respiration dramatically in case of apnea, dyspnea, like whenever there is no respiration like that, body carbon dioxide levels, hydrogen ion concentration, all of them will be increased, and these increased contents, now these will be detected by these peripheral chemoreceptors and central chemoreceptors. They come to the dorsal respiratory group or some sort of inspiratory respiratory center, and the motors go back to the diaphragm, external intercostal muscles, and they regulate or they stimulate the inspiration. This is one of the example condition I am telling about you. Okay guys, this is about the mechanism, and now I would like to also tell you about the role of the vagus nerve in all this mechanism. Role of vagus nerve. So whenever there is an inspiration causes the stretch of lung parenchyma. This stretching, the stretch receptors present, they send the afferent impulses via the vagus nerve to the medulla. So in the medulla we have inspiratory centers. These inspiratory centers will inhibit the respiration. This is a simple flow chart about the role of the vagus nerve in regulating the respiration.